Alright, a cylinder has both its height and its radius changing. Okay, so let's draw a cylinder really quick so we can have a visual. We have that guy, and it goes straight down, the cylinder dotted right there and solid. Okay, so radius, there we go. So it says it has its height and its radius both changing. So if it says changing, as soon as you know it's related rates, then you know you're going to have a dH dt somewhere. This means this is the rate at which the height is changing. There also might be a dr dt, because did it say radius anywhere?
Yeah.
Okay, so there's probably going to be a dr dt, which is the radius changing. So I continue on reading here. It says its height is increasing at the rate of, it gives me the height. So I'm going to put this 3, and we know it's meters.
DHDT?
Yep, meters per minute. Okay. All right, and then it says when the height of the cylinder is 8 meters and its radius is 2 meters, so it gives us some, like an exact, what it's doing is it's giving us an exact point of time, because we know that the height is changing. So it's saying when it's at exactly 8, its radius is 2 meters. Wait, this is just a cylinder, right? Yeah, does the radius ever change? That's weird that they give us the 2 meters, right? Because if I go all the way up, it's going to be 2 meters the whole time. So I'm going to write that down too. So we have the cylinder, the height is 8 at the moment we're talking about, and the R is 2. All right. The volume is not changing. Oh, why is the volume not changing? Oh wait, this says a cylinder has both its height and radius changing. So the radius is changing. So this is, so maybe it's like it's expanding and it's going up at the same time. All right. How fast is the radius decreasing in meters? Okay, so we know that the radius is decreasing. That means it's going to be a negative. So whatever we get right here, we know our answer is going to have a negative on it. So let's just keep that in mind. I did that by noting it. Okay. Now this is cool too, because they give us the volume of a cylinder function. The volume of a prism shape like this is always the area of the base, which is why it says pi r squared times the height. Alright, so we have our volume. Okay, now the way I would always think about these is I go, okay, now I need my rate variables. Do we have our rate variables in here? I don't see any rate variables, and so what we're going to do is we're going to take the derivative of this with respect to time. That's going to give us our rate variables. Our rate variables are these guys, the dH dt, the dr dt. We know... Okay, so let's just take the derivative and see what happens. We get dv over dt. It's kind of like, you remember implicitly deriving?
Yes.
When you derive implicitly? When you, like let's say we had x squared plus y squared equals 25. If we took the derivative of this with respect to dx, this one is like normal derivative. This one is not like normal derivative. But when I take the derivative of this, you treat it like normal at first, but then you have to multiply it by dy over dx. And the reason why we're doing that is because it's kind of like the chain rule. You take the derivative of y squared, and then you have to take the derivative of what's inside of y. And we're assuming y is a function of x, like x plus 2 or something like that. And so we have to take the derivative of what's inside of y. But we don't know what this is, and so that's why we write dy over dx. And then the derivative of 25 would be 0. So that's how you would implicitly derive. Here, we're taking the derivative with respect to t, and there's no t's here. So everything's going to have a dy over dx, but in this case it's going to be d, whatever the variable is, over dt. So let's continue. Now, this pi is a constant, so I'm going to leave that pi out, and then I'm going to have the derivative of these two inside of it. Now, if you see what we're going to have to do, you're not that excited because we have two variables multiplying to each other right here, which means we have to do the product rule. So we would have to do the derivative of, the r squared first, so it's going to be 2r, and then dr over dt, and then times h, so times h. Then we're going to go plus derivative of the second one, which is, the derivative of just h is going to be 1, and then we have to multiply it by dh over dt, so that's why there's a dh over dt there, and then we have to multiply it times r squared. Okay, so that is, that's a derivative of the inside. So now we have our dv over dt, we have a dr over dt, and a dh over dt. Once after we find the derivative of this, now you can see, oh look, we have a dr over dt, which is what we're trying to look for, right? We need to know all these other variables. So hopefully we have all this information. I know what r is. What's r?
R is 2 meters?
Is 2. Okay, do you guys know what h is?
8 is
8. Do we know what dh over dt is?
3.
They give us 3. Now I gotta make sure that's supposed to be positive. It says it's increasing at a rate of 3. So if it's increasing, that means it's positive, right? If it said decreasing, then I would know that's supposed to be negative.
negative.
That's like a tricky trick that they like to play sometimes.
That's a mean trick.
Yeah, it is totally a mean trick. Okay, you see the r right here?
Yeah.
All right, so that's another 2, right?
Yeah.
Okay, so far we have almost all the variables. There's one variable that I'm missing here. Do you guys know which one I need? This one.
That one.
dv over dt. Do we know the rate at which the volume is increasing? I don't see it. I wrote anything over here. Let's reread this. A cylinder has both a height and radius changing. Got that. Its height is increasing at a rate of 3 meters per minute. Okay. When the height of the cylinder is 8 meters and its radius is 2 meters, the volume is not changing. Oh, there it is. It tells me what dv over dt is. So if it's not changing, what does dv over dt equal?
0?
Yep. So dv over dt equals 0. Now let me clean this up. All right, 0 equals pi. Let's write a bigger pi right there. Pi times, we're going to have 2 times dr over dt times 8 plus 3 times 2r, no, it's not 2r, but 2 squared. Alright, and I can simplify stuff in there. So let's go, that's 2 times 2 times 8 is going to be 32 dr over dt. And then that is going to be 4 times 3, which is 12. That's all going to be multiplied by pi, and then that equals 0. Alright, now I'm not going to distribute the pi because I'm pretty savvy with algebra. I know that if I divide both sides by pi, the pi just goes away. Peace out, pi. Okay, and then now I need to get the dr over dt alone, so I'm going to subtract 12 from both sides. So let's subtract 12. Let's subtract 12 over here. So now I have a negative 12. That's cool. That's my negative number that I'm looking for. Equals 32 dr over dt. And then you would divide both sides by 32. So we have negative 12 divided by 32 to give us dr over dt. And that simplifies. What can I divide? I can divide those both by 4, right? Negative 3 over 8 equals dr over dt. And that is our answer. Is it up there? I hope so. That would stink if we got the wrong answer. Negative 3 over 8. Oh, isn't that interesting? Look at that. They don't have a negative. It's decreasing at this rate, but they don't put a negative. I would say that's wrong, but I believe that's our correct answer. That's our correct answer. I think it's wrong that they didn't put a negative on there.